welcome to the webinar Gentry's Tool for Disruptive Cost Reduction. This activity is part of the free webinars that continuing education of Los Andes University make with different faculties, in this case, with the Faculty of Engineering. With this activity, we want to bring you new forms to keep learning at any time of your life. We'll remind you that we will have a question and answer space at the end of the activity, so please send us all your questions you have to Q&A or PNR space. Today is with us Dr. Simon Lidvin. Dr. Simon is one of the founders and executive of TRIZ. As TRIZ CEO, he is responsible for the quality of TRIZ innovation services. Dr. Simon has led numerous international consulting projects for Fortune 500 companies. Welcome, Dr. Simon. We give you the word in order to begin this activity.
Hi, everybody.
Hi, Dr. Simon.
May I start to share the screen?
Now you can share the presentation, Dr. Simon.
Okay. Come back here. Okay. Do you see my screen?
We can see it.
Okay, I am going to the slideshow mode.
Perfect.
And I can start.
Thank you for being here.
Okay, hi everybody. Good afternoon. Buenos dias. It's nice to meet with all of you. Today's presentation is about disruptive cost reduction. Here is the agenda of today's webinar. It will be a brief introduction of our company, TRIZ LLC, that providing this methodology and tools for disruptive cost reduction. And then I'm going to introduce to you some of the specific tools for disruptive cost reduction with case studies. And then at the end, we will have time for some discussion. You can ask questions and I will address these questions. The first is a few words about this methodology called TRIZ. TRIZ came from Russian acronym Theory of Inventive Problem Solving. It was introduced to the world by Russian genius, scientist, engineer, writer. His name is Henry Altshuler, and he introduced several paradigm shifts in innovation. First, instead of analyzing how people are thinking, let's try to repeat how Albert Einstein was thinking. Let's repeat how Thomas Alva Edison was thinking. It doesn't work. And actually, the majority of tools that are very famous today, like brainstorming and some other tools, they are based on the kind of psychological approaches to innovation. Instead of the psychological approaches, the originators of this TRIZ methodology recommend, instead of analyzing how people are thinking, let's analyze the history of products and technologies and use scientific systematic approach to innovation. Like analyze patent collection or the real products and technologies on the market, what are the winning products in the market and why they are winning products. The second paradigm shift of this methodology, theory of inventive problem solving, is to follow the objective trends of engineering system evolution. Products and technologies are evolving not randomly, but there are some objective trends of evolution. Let's say from the very old camera goes to the more modern camera, and finally goes to the today's digital world, digital cameras. And all system goes with so-called S-curve of evolution, where the productivity is in time increases dramatically, and jumping from one S-curve to another with new action principles to perform the same function. That was the second paradigm shift in innovation, making it repeatable, reliable, and scientifically based. Then it was the idea of, instead of optimization and compromising, resolve contradiction, like in this illustration. If you have a high power motor, you need more fuel. And if you would like to reduce amount of fuel, the power will be reduced. That's a contradiction. And TRIZ methodology is not looking for compromise or optimal solution, but resolving these contradictions. And another paradigm shift in this methodology is, instead of trying to get to the solution in one jump, it's used step-by-step algorithmic approach. There is algorithm for inventive problem solving. You can reach the effective solution just doing it these steps of algorithm. Another thing on the picture on this slide, you see the originator of TRIZ, Mr. Henry Altshuler, and myself in 1979. It was 40 plus years ago. I was at that time. And now I'm a little bit older, but still alive. And what recommended by further TRIZ paradigm shift, it's like you have to follow these new approaches of methodology. But methodology was not stopped on classical TRIZ, and we in the company Gen TRIZ, it's a next generation of theory of inventive problem solving. We provide some new paradigms. Like initial TRIZ theory of inventive problem solving, it was about solving, based on the name of methodology, solving engineering technical problems, how to invent. But when the methodology came to the Western world, to the United States, to Europe, to Japan, to Korea, to China, it was clear that people are not looking for just ideas or patterns. They are looking for practical solutions. They need to address business problems, how to increase return on investment, how to increase profitability, dramatically reduce cost. It's not technical problem. It's a business problem. And that's why the new generation TRIZ tools allow to connect business challenges with technical problems and then apply problem-solving tools. Another statement is you should focus on functions, not components, that are very important for the development new generation products and technologies. Like in BlackBerry, there were a lot of buttons, but what are the functions of buttons? Just to navigate through the screen. The next generation iPhone, there are no buttons here, but their functions are performed by the icons. Next recommendation of the methodology is, instead of addressing the initial problem, you see the picture on the left, like you see the top of the iceberg. That's what people are attacking when they are trying to innovate. They see the problem and they are trying to address this problem as is. But what our methodology recommends is, let's find why do you have this problem? What is the bottom of this iceberg? We call it key problems. And we have tools allowing us to find why do you have this problem. In our case of today's webinar, it's a high cost. Why do we have this high cost? And we have special tools how to find these causes of the high cost. The next one, that's a very challenging kind of statement. We are talking about innovation, invention, and we recommend don't invent. The best way to solve the problem is to find the existing solution somewhere in the world. In this picture to the left, it's a funny picture. The solution was found in Mother Nature. The trunk of the elephant is a great tool, and some of today's mechanical tools, they are just using this solution from the Mother Nature. But you can bring solutions, existing solution, not from the Mother Nature, but from some other areas of science and engineering. And one of the tools that I will show you today, called function-oriented search, is based on this principle: adapt existing solution instead of inventing the solution from scratch. Leverage global knowledge. Maybe you know the concept of open innovation. It was introduced by American professor Henry Chesbrough like 35 years ago. Mr. Chesbrough stated that somewhere in the world there are ready-to-go solutions for your problem. But unfortunately, Mr. Chesbrough didn't tell us how to find these solutions. And it was done in our TRIZ methodology. We developed special tools allowing us to find the right material or component or technology that allow you to solve the problem. The next important principle of the science of innovation, innovate against the right target. People are not very good in identifying their needs. That's why when you are buying something, you have in mind 2 or 3 basic parameters that you are evaluating the product. Would I buy it or not? And we develop a tool called main parameters of value discovery. Main parameters of value are features of the product or technology that people on the market will pay for. And we are not asking people on the market, like marketing people. They are coming to the market and asking people what you will pay for. But unfortunately, marketing tools are in many cases very misleading. What we develop in addition to this voice of the market, we develop several tools. We call it voice of the product. We analyze the product or technology itself, analyzing what kind of new functionality could be provided for the market. And then ask people, would you buy this new feature? And if the answer is yes, we found the winning feature for the new product on the market. And the last bullet here, in many cases in the past, the innovators, they developed a lot of ideas or even patents, but these ideas were not practical. Just for the case of your knowledge, the world patent collection is several millions of patents. But do you know how many of them became the real products on the market? Less than 4%. 96% of all patent collection is just piece of paper, not practical. Among these less than 4% that became products on the market or technologies, less than 10% are successful products, which means that only 0.3% of all world patent collection creates the real advancing and winning products and technologies on the market. Awful statistics. And what we, in our methodology, we are focusing on developing real practical solutions, not just ideas, not blah, blah, blah. Okay, now it's time to talk about the specifics of this webinar, cost reduction. And first, just to remind you, a couple of slides, reminders for you. What are the typical sources of cost? You see here, it could be labor cost, operational cost, capital cost, materials, energy, regulations to be sustainable, the product and technologies, cost based on losses and base, depreciation and overhead costs. There are a lot of sources for cost, and all of them should be considered if you are going to reduce cost disruptive. The next important thing, what are the product life cycle, the stages of product technology life cycle? Because if you would like to dramatically reduce cost, you should go through all these stages of product life cycle, like development stage, production stage, packaging, transportation, storage, exploitation, maintenance, recycling, marketing, and so on and so forth. All these stages of life cycle, they are associated with some cost. And sometimes packaging is more expensive than the product itself, or maintenance is extremely expensive, or for ecologically not friendly product, but sustainable product, the recycling and technology or disposal is very expensive. I will show you one case study regarding this situation. Okay, what are the traditional approaches to cost reduction? There are some tools that people are using in the world, and they were invented in the United States, in Japan, in South Korea, in China. For instance, target costing, the best results of target costing are usually 30% cost reduction, but normally it's 5 to 10%. Just in time, Japanese method usually reduce cost also 10%, but maximum 20 to 30%. Lean also 20 to 30%. Management audit 20 to 30% as well. Kaizen, another Japanese technology, also up to 20%. Not one of these approaches could reduce cost, let's say, 2 times or 3 times. Everybody believes that it's impossible. But we are talking about disruptive cost reduction, and all the tools that I will show you in this webinar, these tools are tools for disruptive cost reduction. TRIZ methodology has about a dozen of these tools, but we have some limited time for this webinar, and I selected 3 tools and several case studies showing how it works. Let's go there looking at these tools one by one with some case studies. The first one is so-called trimming technique. Trimming is a tool of TRIZ methodology that allows to remodel the product or process or service in a way that we eliminate some components from the product or process, but keep its functionality by redistributing the function of these components to the the rest of the components, or to the super system of this product. For instance, this chair on the right side, it doesn't have any legs, but it works perfectly without the legs, because the function of the legs was transferred to the seat of the chair. and completely elimination of costly components of products or operations from the process should be without any deterioration of the this product or process functionality. And what's important, this training problem sounds counterintuitive for engineers and scientists because, people create some products and processes, perform some functions. How can they survive without this component? People are kind of very reluctant to accept not the solution based on training, but even training problem statement. You will see in my case studies. Training technique achieves this challenge by redistribution of these functions of trained components between the other components. We have special algorithms and tools allowing us to do it. Let's look how it works in some specific case studies, because case studies shows much more effectively how it works, because it looks like it's impossible to get rid of the expensive components from the system. Okay. Training is a major TRIZ tool for disruptive innovation. Let's start from the first case study. It's a product that is produced by companies that all of you know, General Electric. And one of their business units produced the device that is sitting in each wall of your office and your house. When you switch on and switch off the light in your office or in your room, you use this device in the wall. It's called snap switch. And what was the problem? The General Electric produced this device for many years. Very lucrative business, very good device. But the patent expired, patent of General Electric. And the next day after expiration of the patent, Jose, I see your cat, it's so beautiful.
Thank you, Dr. Simon. I want to ask you a favor, please. Can you come closer to the computer? Because we are listening a little bit of noises when you are talking, or we can try the headphones. I don't know.
Is it better now? I'm closer to the computer.
I think we should go back to the headphones.
Okay, let's go to the headphones.
Let's see if it works. If the systems are that they can't listen you well.
Is it better?
Yeah, it's better.
Okay, good. Let's continue.
Thank you.
Okay. Let me repeat the initial situation of General Electric. They produced this device for many years. Very lucrative business for General Electric, but their patent expired. And next day, two Chinese companies started to produce the same device, but 2 times less expensive. The cost of the Chinese device is 2 times lower. You believe that General Electric has good engineers, designers, scientists. They tried their best trying to reduce cost 2 times, but they could achieve only 15% cost reduction. They need really, and they applied some tools like Kaizen, like Lean, only 15% cost reduction. What they asked us to reduce cost dramatically means 2 times. They need to compete with Chinese competitors. And we analyzed that there are 2 problems in this device. First of all, the
plastic parts of this. There are a lot of cost centers in this small device, but the plastic parts, the case and the cover, they are very expensive. It's a special plastic to withstand the electrical current, high electrical current. And the assembly of these devices is pretty sophisticated. And we focused on these two cost centers, but totally we developed a dozen of solutions for General Electric and reduced cost 3 times, and Chinese were out of business. But let me show you just one solution that we reach using trimming technique, this elimination of some components. Okay, first of all, in order to apply trimming, the first step is to build functional model. Each component performs some functions. What are the functions of the case? We are talking about this plastic part that you see on the left side. The case, the major function of the case is to hold the electrical parts of this device, the connector called connector here on the chart. And the cover, its major function is to stop your fingers or dust particles or moisture to get inside of the case. And now we should apply trimming. We would like to reduce some components, costly components, and we get rid of the cover. Now we have only the case. You see, it sounds crazy. And the trimming problem here is how to make the case to perform all functions of the cover. It's a new functional model where the case perform function of the cover, stop fingers, dust, moisture particles to get inside. When we formulated this trimming problem to General Electric managers, engineers, designers, they said, guys, you are crazy. It's impossible. And we asked them, why? They said, because in order to close something, we should close this case. We should have 2 pieces. We should have a cover. And we said, okay, let's formulate a contradiction. Contradiction here is the case should consist of 2 pieces in order to perform all functions of the cover. But the case should consist of just 1 piece in order to reduce the cost. It's what we call a contradiction. After this formulation of this contradiction, the General Electric guy said, oh, guys, you are completely crazy. What strange problems you are formulating? It's impossible. But we say, don't worry, we have special principles of resolving contradictions. And one of the principles is how to resolve contradiction in time. We need to case to be in 1 piece during manufacturing. When we're manufacturing, it should be 1 piece. But when it works, it should be 2 pieces. That's the principle of resolving in time. And we have some recommendation. One of the principles of resolving contradiction is instead of 1 piece, use 2 identical pieces. Here is the solution that we provide. We have 2 pieces, but they are identical, absolutely identical. In terms of manufacturing, it's 1 mold, and you produce just 1 piece, and then assemble these 2 pieces in 1 case. Like here, you see, you turn it and it works like here. And here is the business impact. By doing that, we dramatically reduce the amount of materials. The assembly is much easier with this solution. Only this solution, we got 45% cost reduction. Remember, with multiple solutions that General Electric tried themselves, they achieved only 15%. We achieved 45% with just one solution. And we developed a dozen of these solutions and totally reduced cost 3 times. And you see, it is a disruptive cost reduction. And we did it, General Electric engineer says, guys, it's like a soccer street what you are doing. No, it's not a soccer street. It's a step-by-step algorithmic approach. We build functional model, we formulate the function, we formulate the training problem, then we formulate it in the shape, in the form of contradiction, and then using principles of resolving contradiction, we got to a solution. That's how it works. Okay, another example from absolutely different industry. It's a company, you all also know this company, it's Procter & Gamble. And they are producing the peanut butter. Peanut butter is extremely popular in the United States, in other countries, especially kids, they like this sweetie product. But you know that many people in the United States are overweight, and that's why the companies are trying to reduce the caloric value of the products. They call it low-fat products. And they developed a new product, low-fat peanut butter. In order to reduce caloric value, they eliminated 40% of fatty load butter and substituted with some powders, corn syrup and soy proteins. In order to do it, they should mix this peanut butter, which is very viscous liquid, with 40% of the powders. And in order to do it, to have a homogeneously mixture, they use 3 steps of mixing. First, they use traditional auger mixer, then 2-disc mills, and then jet mixer. Only after 3 stages, they achieve the homogeneous mixture of the peanut butter and these ballast powders. What was the problem? Of course, the problem was it is very expensive, this additional equipment, and the cost of the low-fat peanut butter is 50% higher than normal peanut butter. That's why this product was not popular on the market, too expensive. How we solve the problem? We again apply trimming. We need to trim some of these extra operations, optimally all of them. And trimming problem we formulate in a way how to make the order, just one device, to perform functions of disc mills and jet mixer. Again, when we formulated this problem to Procter & Gamble engineers and technologists, they said it's impossible, even theoretically. We tried it, and we need these 3 different pieces of equipment. And then we apply the tool, then we will talk about it a little bit later, but I will introduce it right now. We found the existing solution. We formulate the initial function to mix low-fat peanut butter with ingredients. Then we generalize the function. Where we should look for solution. In some areas where this function is more important than in production of peanut butter, we formulate the generalized function in a way how to move powder particles relative to viscous liquid, some physical kind of problem. It's a scientific problem, not a technological problem anymore. And we found the leading industrial area where people are good in performing this function, the production of cement or concrete. And we found this solution in concrete production to use vibration. And here is the solution. I will show you. We propose to vibrate this auger mixer with a frequency of vibration equal to own frequency of these powder particles. After applying this vibration, this high viscous liquid started to behave like water. And here is a business impact. We completely eliminate disc mills and jet mixer at all. One piece of equipment instead of 4. Productivity increased 2.5 times. Footprint of this production reduced 3 times, and capital cost reduction more than 40%. That means that low-fat peanut butter, this new peanut butter, is just 5% more expensive than normal peanut butter, which is absolutely acceptable for the market. Okay, the last case study to show you how effectively training works is in the paper production technology. You know that paper production is a very old industry, people producing paper for centuries. And what was the problem? It's extremely expensive process. The paper making machine, it's like a 3-story house, and the price of each machine from $200 million to $400 million. It's extremely expensive. What our client asked us to do to reduce the capital cost of paper making. And the brief initial analysis shows why the capital cost is so high. The paper production uses a lot of water for producing the paper. 1 ton of water is used per 1 kilogram of dry cellulose fiber to produce 1 kilogram of paper. Of course, it dramatically increases capital and operational cost, because we should first add this water and then eliminate this water, because the final product shouldn't have any water. And we were asked by the client to reduce the amount of water and correspondingly reduce the capital cost. And their desire was to reduce capital cost by 5%. You understand that if the price, the cost of the machine is $400 million, $400 million, 5% means $20 million. Huge saving. That was their desire. Then we apply training. First of all, again, we build functional model, formulate functions of 3 major stages of paper production. First, it should be made so-called paper pulp. They are adding water to the cellulose fibers, then heat this pulp and mix it to make it homogeneous. Then they distribute these fibers onto the conveyor, file conveyor. It's a huge conveyor. And the function of this is to distribute fibers and to create hydrogen bonds between cellulose fibers. And finally, paper drying. Of course, it's a simplified model, but these are the major functions of the paper making process. Then we formulate the training problem. First of all, what are the functions of water? We formulate the 2 functions of water. First, to bind fibers physically by hydrogen connections. And there is a need of 1 kilogram of water per 1 kilogram of dry cellulose fibers to perform this function. And why do we need 1,000 kilograms of water? To perform the other function, to distribute fibers. The major part of the water is perform this function, to distribute fibers. Okay, now we formulate this key problem. what is the problem that should be resolved in order to reduce cost dramatically. How to distribute cellulose fibers without water. Could you imagine the reaction of our client? They said, guys, we are crazy. It's impossible. Even theoretically, people are producing paper for 1,000 years, and it cannot be done without water. We said, okay, guys, we know how to do it. We should put this function of distribution of fibers to something else. And we developed a solution. We propose to use steam instead of water for fiber distribution. What is steam? It's a gas it's a water in a gaseous phase. And it's enough moisture in the steam to create this physical binders between the cellulose fibers. But there's no water in this process anymore. This was a solution. Okay, now see the results of this solution was implemented, and today is a new revolutionary solution in paper production. Capital cost reduction, 28%. Remember, their dream was 5% cost reduction. We reduce cost 28%. It's a really, really disruptive innovation. The energy consumption reduction, 2.5 times. Water consumption reduction, 500 times. Almost no water at all, just steam. Because of that, the sustainability of this technology increased dramatically. No need for water recycling. In the past, with this lot of recycling water, it was very costly, first of all, and secondly, the technological process was not environmentally friendly. The paper production plants, they were paying huge penalties to the government. And energy consumption reduction 2.5 times. And what was absolutely unpredictable to the client, yes, we reduce cost disruptively, but the quality of paper became better, because when water distributed fibers, they were oriented in one direction. Water is pushing the fibers in one direction. When you're using steam, the fibers are not oriented in one direction, which makes them, the paper, more strong, much better than in the past. That was absolutely unpredictable, great result of this new revolutionary technology. Okay, trimming, you understand. Two more tools of disruptive cost reduction, and we will be done with this webinar, and then we will discuss the, and you will ask your questions. The next one, remember I told you, we need to address not the problem as it was stated, but find what are the causes of this problem. And the tool is cause-effect chain analysis. We formulate the initial, the target problem, high cost, excessive cost. But why? Why you have this high cost? There are specific causes of it. And we are trying to find some deep scientific, chemical, physical, biological reasons why it's so high cost. And we use this tool, cause and effect chain analysis. We're trying to find these fundamental causes that we call key problems. Okay. Let's skip these ones and go to the case study. The case is from the company, also in food industry. All of you know the tea bags, but there is a product on the market similar to tea bags, but for coffee. The same looks absolutely the same, but inside is not tea but coffee, but not the instant coffee, but grounded coffee beans, which makes this coffee natural coffee. Because instant coffee is not natural, it's extracted coffee, and the taste of instant coffee for coffee lovers, they don't like instant coffee. Here, these coffee bags, you have the same taste as normal coffee. But it's much more convenient, just like tea bags. Put it in the your glass and put some hot water, and you have coffee. But what's the problem? It's kind of contradiction. The pores of this paper bag are too small to keep inside this grinded coffee. And these small pores, they restrict the, it should be extraction of coffee by hot water. And with small pores, it's not so easy to extract coffee from the bag. It takes more time to extract, and you should just dunk this coffee bag into your jar or into your glass of coffee. And in order to make it more effective, what they recommended just to put more coffee into the bag. Great, in this case, if it's more coffee, the extraction is better, but the cost of the coffee bag, it's too expensive. Or they put two times more coffee. Correspondingly, the cost of the product almost 2 times more expensive. Okay, what was their project goal? They asked us to reduce the cost of the coffee bag for 10 to 15%. It will be a great business impact if we can do it. You know that we are focusing on disruptive cost reduction, not 10 to 15%, but dramatically cost reduction. Say 2 times cost reduction. That's our target of TRIZ methodology. Okay, then we built the cost effect chain model. We started with excessive cost of coffee bag, and then asked questions, why? And there are several causes, but the main cause is, as I said, excessive amount of coffee. Why we have excessive amount of coffee? Because of insufficient use of this coffee. Why it's insufficient? Because of low rate of coffee extraction from the bag. And here are 2 causes of it. First of all, why it's not effective? Because the temperature of water is pretty low. The higher the temperature, the better the extraction. Why it's low temperature? Because water is cooling very fast. Why it's cooling? Because we are dunking the bag in our glass. You know, it's why we are dunking? Because we are trying to have better extraction. But that's not the only cause of this problem, lower rate of extraction. Another is because the circulation of water is insufficient. Why? Because there is a high hydrodynamic resistance of the paper bag. Why? Because pores in the bag is too small. And the third cause, it was absolutely unpredictable to producers of coffee bag. We figure out that in each source of water, there are some ions of sodium or magnesium, and even is very small amount of these ions that dramatically reduce the coffee extraction rate. That's why we focused on these two problems. I will show you the solution for this one. But what's important here, nobody even tried to formulate this problem. What is the problem? How to eliminate effect of these ions to the coffee extraction. What we developed the solution is we offer to add to the coffee bag some particles in it's very well known in physics called ionic particles that have the charge of the ions opposite to the ions of sodium and magnesium. These ionic particles are low cost, they are inexpensive at all, and they don't affect the taste or flavor of the coffee at all. And here is the, they are absolutely neutralize the ionic particles. The result, with this new design, amount of coffee in the bag was reduced 2 times. Remember, they wanted to reduce cost 10%, they reduced cost 50%. It was a disruptive cost reduction. And the total coffee bag cost was 40% cost reduction. Okay, the last piece of information for you, the last tool of disruptive cost reduction. Trimming and cause-effect chain analysis, they are not kind of problem-solving tools, they are problem formulation tools, how to formulate problems in a way that nobody tried to do it, and then solve them with some other tools. And function-oriented search, it's a tool for problem solving. The idea of function-oriented search is how to find, remember this open innovation idea, how to find the effective solution somewhere out of your industry, somewhere in the world where these solutions already exist. And because of different industries, they have some functionally similar problems, functionally similar processes. That's why in some industries, this function is already addressed in a more effective way. We call these industries leading areas. And people in these leading areas where this function is already addressed, people already spend some money and efforts developing existing solutions. We should go to this leading area and bring the solution from the leading area. The algorithm for this disruptive cost reduction tool looks, you see in the bottom of this slide. First, formulate the function you should to perform. Then generalize this function to look not in your area, but in some leading areas. Then identify these leading areas, leading industries. Then find the existing solutions from this leading area and adapt these solutions to your initial area. My last couple of case studies showing how it works. The first case study on function-oriented search. Another client of ours, Intel, that is producing microchips. What was the problem? They, of course, producing microchips not chip by chip. They are making so-called wafers. It's a semiconductor disks that contains thousands of future microchips. They cover this semiconductor wafer with photosensitive polymer called photoresist. By dropping a droplet of photoresist on the surface and then rotating this wafer to equally distribute, make a thin layer of polymer film on the surface of the wafer, and then illuminate this wafer with ultraviolet to create the microchip structure. What was the problem? The photoresist, it's a liquid. And in any liquid, like in water, in your tea, some air is saturated in the liquid. And when they rotating the wafer, sometimes the air goes out of this liquid, out of this photoresist, and the bubble appears on the surface. And because of rotating, the so-called bubble track you can see on the surface. And if you have one bubble track on the surface, the entire wafer goes to the garbage bin. Now see to this number. Up to 20% of the all wafers goes to the garbage bin. Could you imagine Intel, 21st centuries, and they throw away 20% of the product? Of course, they are recycling it, trying to reduce losses, but still, it's a huge bottleneck of their technological process. What was the goal of the project? They would like to reduce the amount of waste because of this bubbling. And their goal was like, if you can have not 20%, but let's say 10%, it will be our dream. Okay, but we are looking for disruptive cost reduction. It should be no bubbles at all. We apply function-oriented search again. What is a specific function we would like to perform? We need to remove bubbles from photoresist during dispensing. Now we should generalize function. Forget about photoresist. Forget about these microchips, wafers. Generalized function we formulated how to control bubble formation in any liquid. We will not be looking for solution in area of polymer science like Intel did. They tried to solve the problem by themselves for a year. They asked university professors to help, experts in polymer science, in photoresist, and they all failed. And we apply the methodology, and in a couple of weeks we develop a solution. Okay, now generalized functions how to control bubble formation. What are the areas or industries where controlling bubbles or preventing bubbles formation are more important? And we formulated, we found in our databases, especially functionally organized databases, at least 3 areas that are leading for this function. The first one, blood transfusion. If you have one bubble in the blood is a liquid, one bubble in your blood and you are dead. Of course, there are solutions in this blood transfusion. We found several solutions in this area. Scuba diving. You have a couple of bubbles, you have embolia of your lungs, and you are dead. We found several solutions in scuba diving. But there is an industry that entire industry is dedicated for controlling bubbles in the liquid. It's a champagne production. What is a champagne? Champagne wines, it's millions of bubbles in the liquid. We found multiple solutions in this area. And one of them was easily implemented by Intel. What was this solution? So-called ball valve that prevents liquid flow turbulence resulting in preventing bubbles. It looks like this type of valve. And the cause of the bubbling is the turbulence in the flow of photoresist. But by using this spheric ball valve, you can completely eliminate turbulization of the flow and there are no bubbles at all. Here is a business impact. Waste water wafers of wafers is 0 instead of 20%, just 0. Annual cost savings more than $20 million. It's a disruption, and instead of more than 1 year of trying to address these problems, just in 2 weeks we develop a solution. Okay, the last case study also this function-oriented search. People are usually asking me, the majority of your case studies are from industries, from products, technologies. What about services? And my last case study is from services. It's about hospital. In the United States, hospitals are like business. They provide services to customers, the patients, and they're paying money, or the insurance paying money. What was the problem? The admission process. When you are coming to the hospital, sometimes you could be admitted very fast, let's say within half an hour, but in some cases, it's up to 3 to 4 hours. And sometimes people are dying in the emergency room. And why it's an economical problem for a hospital? Because relatives are suing the hospital if their, let's say, parents passed away sitting in the emergency room. It's a huge economic problem for the hospital. What was the goal? To reduce, they say, dramatically reduce patient admission time. Instead of 3 to 4 hours, it should be not more than 1 to 2 hours. That was their dream. And you understand that our dream will be much, much bigger, higher. You will see what was the result of our project using function-oriented search. Now we use function-oriented search. What is the function we should perform? To evaluate the patient in the hospital by doing a lot of procedures, tests, interviews, and so on and so forth. It takes a lot of time. Nurses and expert and medical doctors are doing it one by one, and it takes time. What is the generalized function? To perform multiple operations on an object in a short period of time. We are not talking about hospitals anymore. Where in the world people are performing multiple operations on the object and in a very short period of time. And you know where we found a solution? What was the leading area? It was Formula One race, so-called pit stop. You know that in pit stops of Formula One, the team of workers, they are changing, substituting the wheel. In the past, it was like half an hour or minutes, but now it's done within seconds. How they are doing it? A team of highly professional people, each of them doing one operation at a time, and they are doing it in parallel. We propose the same approach for a hospital. Multiple nurses and doctors are serving one patient, and you see the result. Instead of hours, it's 8 to 10 minutes. The admission of patient time. Hospital cost of business was reduced 25%. Because eliminating of any legal cases, because people stop dying at the emergency room. Annual cost reduction, more than $10 million. That's it. And now the conclusions. Conclusions, what you should take out from this webinar. First of all, cost reduction is a major direction of innovation. Even incremental cost reduction is extremely challenging. People are not good in developing solutions when they're using just brainstorming and just trial and error approach. Doesn't work. TRIZ methodology has several approaches and specific tools enabling not just cost reduction, but disruptive cost reduction. I shared with you 3 tools, training techniques that allow to completely eliminate some costly component from the product or costly operation from the process. Cause and effect chain analysis allow to identify why you have this high cost and attack the right problem, key problem. Function-oriented search allows to find the existing solution. Don't invent from scratch. You will spend your life trying to implement your solution. Find existing solution and adapt it to your problem. And based on this and some other tools in our methodology, we were able to develop hundreds of products and technologies and services with this disruptive reduction of the cost. And what's important, the cost reduction innovation project does not require a significant investment because it pays for itself. You reduce cost, and this cost reduction saved money allowed to pay for this innovation project. That's why for the university people, you have your own labs. You can provide this innovation project, cost reduction projects for the companies that you are associated with, and you can get some business, some money for university. Actually, that's it, and I'm ready for your questions. Thank you very much. Muchas gracias.
Thank you very much, Dr. Simon. So we start with the question and answer round. So please send us all your questions in the chat, please. We have a few questions. The first one is from Francisco, and he asked us, Dr. Simon, do you have an example of non-industrial process like logistic or commercial ones in which we can apply the model?
Of course, I do have a lot of cases for non-industrial, and I just demonstrated a case from hospital. That's exactly what you're asking. I have a lot of these cases.
Can you give us another one in order to Francisco?
Okay, we performed a project, a cost reduction project for one of the biggest bank in Russian Federation, Alpha Bank. It was about their services. They are one of their services to provide credits for different groups of population. And the problem was that the credit, people would like to have some big money credit, but it cannot be done without verification of your identity. And it takes time. That's why you cannot get the credit in less than, let's say, 3 to 5 days. But you need money right now, let's say, to buy a car or to buy something very fast. And we developed, they would like to reduce the time from 3 to 5 days to, let's say, 1 day. And we developed a solution for them that reduced this time and corresponding cost of the solution. Now people could get their credit in 10 minutes, which was a revolution in the industry. And you see, it's not industry, it's banking. It's typical processes in services.
Thank you, Dr. Simon. We have a second question by Diana. She asked, just a second, which techniques do you recommend for cost reduction in a service company?
Diana, my recommendation is to use the entire innovation process of TRIZ based on TRIZ methodology, because our innovation project with disruptive cost reduction, we are not using just one. I simplified it for you just to show these tools one by one. But in our project, we use them, integrated them in the process or innovation process. First of all, we identify the right target for innovation, what main parameter of value should be addressed. Then we use several tools, not one, using several tools for formulating right problems, like tools like cause-effect chain analysis or training. We have multiple tools. Then we address these problems with our tools like contradictions or resolving principles or function-oriented search. Again, I showed you only a small part of our tools in our toolbox. That's why the answer to your question, I cannot tell you, use just training. No, it will not work effectively. You should need the entire process. It doesn't take a lot of time. Juan here knows that even with huge problems like this paper process, it's a huge process. We spend not more than 3 months in the project. It's not like years that you should spend. Usually it's weeks or a couple of months. It's doable, but you should use not one or two tools, but the entire process. If you ask me a different question, which tool is my favorite? I will tell you. For problems formulation, it's training. For problem solving, it's function-oriented search.
Which one is your favorite again, Dr.
For a statement, it's training, and for problem solving, it's function-oriented search.
Okay, thank you, Dr. Simon. Well, those are the questions we have right now in the chat. I don't know if anyone of the assistants want to ask another thing to Dr. Simon. So please send your question to the chat, and I will read the question to Dr. Simon. Let's wait 1 minute. Let's see if anyone else.
And because this presentation will be available for the audience, we can send to you. It's in a PowerPoint, no, not in PowerPoint, but in PDF format, and Juan here will send it to you.
Okay, thank you, Dr. Simon. Well, I think that is we close the space of answers and questions. Thank you, Dr. Simon, for your presentation, and to the assistant for sending these questions. We just share a link in the chat. We ask you to open before you leave. It's a short survey in which you can tell us how it went in this activity. This activity has been recorded, and you can see it again in the page we share you right now in the chat. In this link, you can also find other activities like this one that we have scheduled already. For example, we are going to have, just give me a second, I will show you.
While you're waiting, I can share with the audience my favorite joke. We are all in this era of coronavirus. And my favorite joke about coronavirus is that humans, as you know, are carriers of the intellect. But for some people, it's asymptomatic.
Dr. Simon, I was telling you guys that we invite you to the next webinars we are going to have next week on Monday at 5:30. We are going to have the webinar. This one is in Spanish, que son los estudios de moda hacia una aproximación crítica. And on Tuesday at 5:30 we'll have las matemáticas detrás de las redes sociales. Mathematics behind social networks. Very interesting webinar. So everyone is invited to assist.
Thank you very much, Jose, for moderating this webinar. Great job. Thank you.
Thank you, Dr. Simon.
Gracias.
Again, thank you all very much for participating. Also, to those who join us on Facebook Live, we hope this activity has been interesting for you and that you continue to join us in the rest of activities we have. Have a happy afternoon, and thank you very much for participating. See you next time.
Bye-bye. Take care.
Take care, Dr.
Stay healthy, stay safe.